Hi, good morning. I wanted to make a short video to go over this week's material. So let me share my screen real quick. If we come into the course, go to modules and come down to week 3. So we're going to go into week 3's PowerPoint. Full screen. So if we look at what this week's about, it's about the cabling, network and cabling requirements, and then some of the documentation and change management. So one of the first things that you'll probably notice is there's a lot of acronyms in this week, such as the ANSI, TIA, and then there's the EIA as well, 568 standard. And you may have run across this when you look at cabling, like patch cables, whether they're a crossover cable or a straight through cable. They'll reference this. And this whole concept is referred to as structured cabling. So where and how is the cable installed in the facility, whether it's a building or wireless or whatever it is, right? So another thing I want to mention is this term demarc. And the demarc is, where does the ISP or the phone company and their equipment and their responsibility, and then where does the corporation or the enterprise take responsibility? And that point where the ISP ends and the company begins is known as the demarc. And it's sometimes you'll see it referred to as a minimum point of entry that will go there. And then the main data frame is where the demarc is located. So this is like the main area where the equipment and the technology comes into the business. And then after that, we have the intermediate data frames, which may be in different areas. So like here shown a different building, each one has an IDF that is home run or connected back to the MDF using here it's shown backbone, which probably would be fiber. And then this IDF, which is in the same building, would probably be copper or category cable. All right. So there's some terms here. The demarc, again, marks the location where they take over the main distribution, and then the IDF, the intermediate distribution frame. All right. So there's some pictures here that show that. Here's the ISP's fiber that comes in, and then from there it goes to our Ethernet switching equipment or routing equipment that will then branch out into all the other IDFs. All right, here's a nice clean looking patch panel on a rack. If you go into building 404 on Thursday, look at the back of the room. We have one of these patch panels that we use to cross connect all of the machines in room 404. So your workstations cross connect to a patch panel, and then the patch panel connects to a switch, and a switch then connects to Mount Sax network. All right. So here's just some examples with voice over IP phones, legacy phones, and so forth. So telephony and networking have merged, right? You're probably aware of that. And the modern utilization of voice over IP phones is in full force. Almost everywhere has switched over to that. And it's just another area of additional responsibility for IT, right? The network technician now, not only do you need to work with servers and switches and routers and Linux machines and Windows machines and Mac machines, but now you have to work with phones. So it's fine because it's just another IP-based device. So the concepts of our networking skills apply the same to the phone as it does for anything else. All right. And then this is just showing the MDF branches out into the IDF, and it just completes our star topology of all of our networking equipment. All right. So let me get down here to another concept that I want to talk about, and that is the copper cabling, which is primarily used in our horizontal cabling, has a maximum length of 100 meters. So the standard, the category 5 or 5E or 6 or 7 or whatever cable we're using has a maximum length of 100 meters. So that's a total length from the IDF or the data room to the jack to the workstation. So the maximum that can add up to is 100 meters. If you go beyond 100 meters, you'll start to see signal loss, which is known as attenuation. So when the data signal reduces over distance, that's called attenuation, and it can lead to data errors on a system. So with the category cable, that's 100 meters. With some of our fiber cable, that can be in the thousands of meters, right? There's some single mode fiber that can run 10 kilometers, so 10,000 meters, which is, almost 6.5, 6 1/3 miles. So that's a good run for a single piece of cable. But of course, fiber is more expensive than copper. All right, so here's showing a typical unshielded twisted pair cabling, where it comes in through the horizontal cabling to the wall and then patched out to the workstation. So this is a typical design, and this is similar to room 404, right? We come into our switch, first we cross connect from the switch, boom, across to the wall into the workstation, and away we go. All right, here's some terms here. One of the things that is important is this bend radius, where with category cable, the bend radius is approximately 90 degrees. So you can bend the cable normally in a loop at no more than 90 degrees, where with fiber, the bend radius is almost 45 degrees. So that means that the maximum you can bend it is about half as you can with copper cable. So that's an important thing when you're running cable. You can't just bend it around corners as aggressively as you'd like, otherwise you'll have data loss. And another thing here that you probably heard in your electronics courses is the electromagnetic interference. And we know that when a conductor is next to another data source or voltage source, that magnetic energy can transfer and interfere with the other conductor. So what they've done with like fluorescent lighting is they will use shielded twisted pair, STP, which has a foil wrapped around it to eliminate some of the EMI. Another resource for that would be conduit that you could use. Another thing you could do if you're in a high EMI environment is use, why can't I think of a fiber optic cable? Sorry about that. And now that is immune to EMI. And then this term plenum cable, that's referring to plenum, which is the area above the ceiling, normally where our air conditioning and HVAC is. And the plenum cable will not, when it catches fire or melts, release a hazardous chemical. Regular plastic, if you've ever smelled burning plastic, it's very toxic, and extended exposure to that can cause problems with your respiratory problem. So the last place we want that is in our air conditioning ducts, where that poison can be, distributed through our HVAC. So plenum cabling prevents that. All right. And then the the last thing here, you can read through all this, but the second part of this lecture is on documentation. And documentation is not the most exciting part of the job, but if you've ever taken over a job or a position from somebody that was good at documentation, it makes your transition into the work environment much, much better than if you inherit a position from somebody that did not do a good job of documentation. And the next thing worse to no documentation is poor documentation. So if you want to impress your boss when you get hired, go through and read the documentation and then update it, right? And make sure you kind of get the lay of the land, and it's really going to help you understand what's going on in your network. There are tools that we can use to map our network. The Nmap and ZenMap are the most common. ZenMap is just a GUI version of Nmap. And Cisco has stencils. So these symbols here are showing network industry standard symbols for a router, a switch, a firewall, and those are common. And we'll work with that here in the next coming weeks, where we'll use a product from Cisco called Packet Tracer. We'll start building some of these diagrams and testing them with our network skills. All right, so there's a couple of diagrams that we should be aware of. One, the network diagram is just an overview of either the physical or logical topology. A wiring schematic is like a blueprint. So it's a detailed, shows where every wire interconnects. A rack diagram just shows our rack mounted system. So if you walk into a data center or a server room, you don't have to guess, well, which one is server R3? You know, you go, okay, here's R1, R2, R3 is this one. And you can, work on it quicker. The wiring diagram here is just showing, the cable, where they run. Now, this is more of a logical topology because it gives us an overview of how the data transfers, whereas a physical topology would have room numbers, cable types, what conduit these wires are in. So it'd be more of a physical location, whereas a logical just kind of gives us how does the data travel. So we see signal comes out to the WAN, and it comes from station 3 into this switch, and then into this switch, which then goes to the ISP. All right. There are some other terms in the rest of this chapter that I'm going to leave to you. The standard operating procedures are just written to explain how things should be done. And every company will probably have their own internal standards. There'll be some similarities between different organizations, but the old adage, the more organized you are, the easier it's going to be to manage things, definitely is true. So you should have documentation that tells you, what vendors you use, what companies you have service level agreements with, right? Maybe you're paying for some support technology from one vendor, and what does that include? Is it 24/7? Is it, 5 days a week, 8 hours a day? You should have access to all that. And then the last section here is just with the inventory management. And one of the key things here is the naming convention. And naming conventions are kind of a individual or institutional standard. Like Mount SAC likes to do the room, the building, and then the division. So like room 404, building 28B, tech and health. So if you just see the name, you know what room it's in, what building it's in, and what division it's in. And other places will just maybe have, L1 dot Mount SAC dot 404 or whatever. It may be different. I've also worked at places where the naming conventions are abstract. You know, there was I was in a data room looking at servers, and all the servers were named after Seinfeld characters. So you had Jerry and Elaine and Kramer. Yeah. And then the one that kind of made me chuckle was the mail server was Newman, right? Because he worked at the post office. So that just depends. I worked at another place, or I was helping somebody who worked at another place, and they named their servers after their dogs. So one server was named Max, and another one was named Gidget, or whatever their dogs' names were. So it's as long as you can reference it, it's probably fine. But if you were to suggest something, you'd probably want to have some sort of order and structure to it. All right, and then the very last section that I want to cover are these standard business documents. So you have the request for proposal, where you request a vendor to respond to your request. Like you may say, hey, we need to purchase 6 routers, 12 switches. We need to have it cabled and documented. What will that cost us? And then they'll come back with a proposal. And it really should, if your request for proposal is well written, the responses will be comparable. You know, have you ever had someone come to give you a bid on something, and they just give you, well, it'll be about $10,000. And you're like, well, what does that include? Well, everything. Well, I would like to see how much I'm paying for equipment, how much I'm paying for labor, how much I'm paying for, support or service. Break that down. So if your RFP is well written, it will say, you must itemize the following details. And then that way the vendors, they don't have that wiggle room to say, well, we just 10,000 and 5,000 of that is profit, where you can't see that you're getting taken advantage of. And it makes it easier to compare apples to apples when you look at vendor 1 versus vendor 2 versus vendor 3. Okay, and then a memorandum of understanding documents the intentions of 2 or more parties to enter into a document or a binding agreement. The statement of work says what will be completed. There have been times where you think that the proposal and the MOU says you're going to do this, this, and this. And then the vendor comes in and they say, no, we were only planning on doing this and this. The third part, we never address that. So then you get to the end and you have to find somebody else to do it. And then I mentioned this earlier, service level agreement. This is a binding contract that you normally have. The most common is with your ISP. So when you sign on the dotted line for an ISP, they'll have uptime guarantees. They'll have hours of operation, how long it'll take them to respond to a request, and all that. And in a larger institution, you can hold them responsible. So if their connectivity goes down and you're out of service for more than 5 hours, and their SLA says they guarantee uptime within 4 hours, you may have the ability to say, hey, you missed your SLA by an hour. I want some financial compensation for that time that you weren't able to provide it. And legally, they have to do that. All right. And then there's some other documents here. So that gets us to the end of this chapter, where we looked at the various network and cabling equipment, and then the documentation and some of the change management and the documents that go with that. So I hope that will help you get going if you've been looking through the material this week. And then this week's lab, we're going to continue our build out. We're going to redefine our CentOS server. We'll reinstall that. And then we're going to take a look at some of the inner workings of the VirtualBox networking. So that will be on Thursday from the lab time 6:30 to 9:40. But as I mentioned to many of you last week, I also have another class that has a lab at 3. So if you want to come in earlier, I can open up the room and get you going. And that will work for this week's lab. I'll let you know going forward if the following lab, some of them we're going to work in pairs or in groups, and that won't work well if a bunch of people come in at all different times. So I'll let you know when that is. All right, as always, take care. And if you have any questions, let me know. And I'll see you on Thursday. All right, bye.